Well, hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badruddin and today we are going to solve lab number 10 from web cache poisoning vulnerability module. And this lab is all about the implementation flaw in the web cache. So before going further, this little disclaimer as always for you. This video and its content are only for educational and awareness purpose, and I do not support any unethical or illegal act. That's been said, as you can see here, web cache poisoning via fat get request. So the first thing we need to understand, what is fat get request. So a fat get request is simply a get request with request body. Okay, so we will see that in a minute. Let's go and we see what this lab is all about. So web cache poisoning via fat get request, and the agenda of this lab is vulnerable to web cache poisoning. It accepts get requests that have a body. So a get request that have a body means some content inside the request body. So that is known as fat get request, right? So but does not include the body in the cache key. That means the request contains the body, but it is not included in the cache key. Means the cache will not consider any request body content, right? A user regularly visits this site's homepage using Chrome browser. Okay, so to solve the lab, poison the cache with a response that executes alert1 in the victim browser. Once again, I would like to mention a thing here, that these are the labs, and we already know by reading the content of this lab, we know that what are the specific areas where we need to look to exploit the vulnerability or to find the vulnerability. But in the real life scenarios, you may do not have any prior knowledge about it. So you can identify that, okay, web application is using cache. There is a cache implemented between me and the web server, but to exploit that, to find the vulnerability, to confirm the vulnerability, you may go through many processes, okay, many different processes to confirm the vulnerability, and then you can exploit it. So let's go without wasting time. I already opened up the burp suite, so I'm going to enable the burp proxy on my browser, and I am just going to refresh this page back to the proxy, and here we have all the requests. So as we can see, one of them is geolocate.js, this resource. Fine. And this is very similar request what we solved in the previous lab number 9, where we engage with parameter cloaking. So I'm going to send this request to the repeater, and I'm going to see something. Okay, so this is the response. As we can see, there is cache control which have maximum age 35 seconds, and this response on the 27th second, and this response coming from the cache, right? So let's go and try to change this value, and as you can see, this function is called in the response here. So I'm going to try parameter cloaking first. Let's see. As you can see, it's appearing here. Let's try a few more things, like let's say and I'm going to say parameter 2 is equal to 11111, and I'm going to say parameter 3 is equal to 2222, right? And let's just send the request. Still it will take the callback parameter value, but what if we say this parameter 3 is also callback? Let's see. So as you can see, still it's taking this value, right? So the next thing is fat get request. Here, as you can see, in the body we don't have anything. Okay, so I'm going to clear all of these. This is the first request, right? Now what I'm going to do, go back to the proxy, and with the same request where it loads the geolocate.js, I'm going to right click here, go to the extension parameter miner, then go to the parameter miner again, and here you have the fat get. So it will identify if there is any request body content there. Click it and leave everything default and just make it okay. Go to the extender, come back, and here click on the output, and as you can see here, we already identified that. So there are some evidence. Okay, the application lets user pass parameter in the body of the get request, and this is known as fat get request. So the application let user pass parameters in the body of the get request, but does not include them in the cache key, right? So this is pretty awesome and powerful tool, which is parameter miner, in terms of cache and identifying the unkeyed cache parameters and the headers, right? So as you can see here, if we scroll down a bit, this is the first request. This is the same what we have. It just put here some random parameter and its value, but the interesting part is this. So as you can see here, there are some, if we see the original request here, you will not find any XHTTP. We don't have here any header like XHTTP override or XHTTP method, but here, as you can see, it overrides the method to the post request, and XHTTP method is going to be the post, and then in the request body, this is the request body where it contains some parameter and its value. Fine. So as you can see here, the callback function, now it puts from here to here. So this is now fat get request, because in the body it contains some value, and here it just put the random values. So I'm going back, and what I'm going to do here, I'm going to take this one, I'm going to override it, copy, come back to the repeater. One thing I would like to mention here, if we right click here and we change the request method, so you can see in the get request we have this callback value with the query string, right? But if we change the method of the request, like from get to post, we have this callback parameter and its value as the request body, right? But if we let's say change, let's see, just send this request. Okay, so you can see it's taking the same value here, or I can say just alter this value of the callback and send it again, and as you can see, now this is changed. So what if, because this is the JS file, what if I can do, let's say, alert, and I'm gonna say 11111, right? And just send this request. Okay, send again. Fine. Now go back here and just refresh it. Okay, there is no difference. No difference, right? The thing is, here we actually totally change the concept, and we are taking this as the post request. Fine. So let's just try one more time, because as you can see, in term of post request, here you do not get any response cache headers, right? We do not get here any response cache header. So the concept is totally changed. Now I'm going back to the get request. Click one more time. Yeah, this was the original get request. Now the thing is, we saw in the extender here, this HTTP method override is equal to post. So I'm going to copy this, come back here, paste that, and make sure that you have one line free before you put the body value. Now what I'm going to do, I'm going to just take this and put it here. Okay, and let's change the value. Now we have one callback query string here, and we have one callback as a request body content. Let's see what we have in the response, whether we get this function or whether we have this value. Okay, if we have this value, that means this callback function comes into the picture. So send this 25, because this was the previous request, so we need to keep sending until the cache gets free. 33. Okay, and perfect. Now you can see it's taking this unkeyed callback, which is the request body value. Okay, now it's not taking this function, it's taking this. Now what we can do, to solve the lab, we can just make here alert, and let's say cybersec-radar, and send this request again. Here it takes that. Very fine. Now come back here, refresh this page, and we are getting the request. Fine. And now you can see, congratulations, you solved the lab. This lab is solved because a user is there in the backend, unknown user. We don't know which user is this, but there is a user which is visiting the home page after every 1 minute. So whenever this user visit the home page and get the response, which is maliciously fed into the cache by you as a hacker or a penetration tester, and if that user get your malicious response from the cache, that time you will get this message, congratulations, you solved the lab. Otherwise, once we make refresh, we actually test whether we get the alert or not. So this time we did not get the alert because now the cache is expired and the genuine response feeded into the cache. So as you can see, this is genuine response and 25 seconds. So we need to wait until the cache response get empty or cache get empty. Now as you can see, our malicious response is feeded into the cache, poisoned into the cache. Now if we refresh the page, you can see cybersec-radar, this is the alert. And if we try to come back here, open a new private window and back to this window, copy this, come back here, paste that, hit enter, and every time any user come and visit until our response is poisoned into the cache, every user will get this response, this alert message. So that's it for this video. If you like the content, please like, subscribe and share. See you in the next video. Bye.